Applications of ratios in practice, the golden ratio and Fibonacci numbers. Besides the applications of ratio discussed in the previous tutorial, there is another important and special application of ratio in practice, known as the golden ratio. Thus, if we have two numbers a and b, where a is the biggest which meet the condition, we have the following shown on screen. We say that a and b form a golden ratio, expressed by the letter phi. The golden ratio is a constant number, whose value is shown in the following on screen. Since square root of 5 is irrational, the digits after the decimal point continue on forever without repeating. Let's use the properties of fractions to find a possible relationship between the numbers a and b involved in a golden ratio. Thus, we can write the following shown on screen. We will explain in the algebra section that we obtain the following shown on screen. Therefore, substituting in the previous equation, we obtain the following shown on screen. Hence, the numbers forming a golden ratio must meet the condition, sum times difference equals product. Example 1. A two-story building forms a golden ratio when the ground floor, the highest from the two, is 5.2 meters high. What is the height of the first floor? Solution 1. We have a equals 5.2 meters. We have the following shown on screen. We obtain for the height of the first floor shown in the following on screen. Obviously, it is very difficult to guess which numbers meet the condition to be in a golden ratio. Most numbers qualified for this are not integers, which makes finding the values of a and b an impossible task. This issue was addressed by Fibonacci, an Italian mathematician, who discovered a special sequence of numbers, where the next number is obtained by the sum of the previous two. The first numbers of Fibonacci sequence are shown in the following on screen. For example, 1 plus 2 is equal to 3, 2 plus 3 is equal to 5, 3 plus 5 is equal to 8 and so on. But what is the relationship between the golden ratio and Fibonacci numbers? Well, the more the numbers in the Fibonacci sequence increase, the closer they go to the value of the golden ratio. Thus, we have the following shown on screen. As you see, the values get closer and closer to 1.61803398887, which is the true value of the Fibonacci sequence. Items that form a golden ratio between them produce a very fascinating view that has been used since antiquity in art and construction. This is because the building structures that form a golden ratio are stronger and more stable. We can find the golden ratio in a number of things, including 1. In plants. You can find the golden ratio in the spiral arrangement of leaves, called a phyllotaxis, on some plants, or in the golden spiral pattern of pine cones, cauliflower, pineapples, and the arrangement of seeds in sunflowers. 2. In art, in many cases, artists have been inspired by the aesthetics of the golden ratio and incorporated it into their works. 3. In architecture, the Parthenon in Greece incorporates the golden ratio in many of its design elements. In the 20th century, Swiss architect Le Corbusier used the golden ratio in his modular system for the scale of architectural proportion. The United Nations Secretariat building in New York City was designed using the golden ratio. The size and shape of the windows, columns, and some sections of the building are based on the golden ratio. Example 2. A piece of furniture is 233 centimeters high. How wide must it be to form the nicest view? Width must be shorter than height. Use the Fibonacci series to find the missing dimension. Solution 2. The nicest view is obtained when height and width form a golden ratio. From the Fibonacci series, we have 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233. Therefore, the width must be 144 centimeters as the following shown on screen. This value is very close to that of the golden ratio, so we obtain the nicest view of the furniture by using the previous dimensions. That is all for lesson 4.2.5, and the end of tutorial 4.2. To continue this chapter, please watch 4.3 proportion. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.